Well, I appreciate being here. I'm not a spring rooster either. I appreciate very much Dieter's enthusiasm, and he's kind of kept the point of the spear at the right part of the anatomy to keep this project going that we started with. But appreciate GLK and Mike Maloney's support, and Akers and Taylor Henry's support in getting us all together. So, and I appreciate all of you for coming. June 5th, 1976, the newly completed 300-foot high dam in eastern Idaho broke, released 80 billion gallons of water. It flooded 400,000 acres, caused more than $1 billion in damage, and injured more than 1,000 people. Yet in all of this flood and this tremendous devastation, only 11 people were killed, because when the people were warned, they warned their neighbor. The flood's upon us, and when we see the consequences of glyphosate, it's a tremendous impact and drain on our society, and you'll get a lot of that information, but I hope that as you hear the information, see it today, that when you're warned, you'll warn your neighbor. To do that, we need to understand some characteristics of the flood that's come and that is still to come as a result of glyphosate. Very unique compound. As Dieter said, it was first invented in 1957 by Jim Chang, patented initially by Stauffer Chemical Company as a very strong broad-spectrum mineral chelator used to clean steam pipes and boilers, patented by Monsanto as a broad-spectrum herbicide in 1974, 10 years after Stauffer. And then in 2008 and 2002, it was patented by Monsanto also as a very strong broad-spectrum antibiotic. As an antibiotic, it's toxic to the beneficial organisms, but it stimulates their pathogens like Salmonella and Listeria and Clostridium and those organisms, so that with these three characteristics, you see how they interact and influence all of the activities in society that we value and hold dear to our sustainability. But you can see that it's very persistent in soils. When it was commercialized, we were told that it has no persistence, that poof and it's gone. It's very readily detoxified. And the detoxification process is true because it's a very strong chelator and reacts with you get that detoxification as it chelates your valuable minerals in the soil, your cations, on that capacity. But it's very persistent, so we're seeing 20 and 30 years of glyphosate accumulation in many of our soil, so that as the dam breaks, then we see that entire flood of activity and demonstration. It's an endocrine hormone disruptor. What makes it a good herbicide is that it's systemic in the plant. It moves, it gets the root as they advertise. It's a synthetic amino acid. It's a carrier for heavy metals and can move heavy metals like aluminum and mercury across the blood-brain barrier to increase the severity of toxicity of those materials. It's a growth inhibitor, a DNA mutagen. We were told that there's just one enzyme that it's inhibited, the EPSPS enzyme for the shikimate pathway, so that it can't ever be toxic to mammals, because we're the only living things that don't have that particular pathway directly in our cells. but all of our GI tract, or not all of them, but a good share of them, do rely on the shikimate pathway because that's where the 3 aromatic amino acids are produced. And if we didn't have those, organisms were going to be deficient in a lot of things in the system. Again, if you look at the chelation capability of glyphosate, you'll see that 10 of the 18 essential elements are chelated by this particular chelator or antibiotic, and gives us that opportunity to foul up a good share of our 8,000 or so physiological pathways that we rely on in our plants and our animals. The importance of that chelation and the antibiotic activity against the organisms that make those minerals available is that they act as the cofactors for those enzymes. Now, the enzymes are the things that do the work, the proteins that do the work in the plant or the animal. But it's like having a 200 or a 400 horsepower engine sitting under the hood of your tractor. Doesn't do any work for you until you turn the key on. And it's the minerals that are the activators. So it doesn't take very much of them, just parts per million of the trace elements and a few of the major elements. But that engine sits there until you activate it, and the minerals are the not only parts of the or components of the tissue, but they're also the activators, inhibitors, and regulators of those physiological processes. And so this is the shikimate pathway. We were told that it only inhibits the EPSPS enzyme that you see up at the upper part of the pathway up there because it chelates manganese. Well, it actually shuts this pathway down before you get to the EPSPS enzyme, and it shuts it up with the acetohepulose 7 phosphatase, or Rabino 7 phosphatase enzyme by chelating the cobalt. Well, cobalt's also a part of, as Dieter mentioned, cobalamin, your B12. So it chelates it, shuts down all of those systems. So, but it shuts it down before the EPS actually, but then you look at within that pathway at all the places that glyphosate also shuts those down. So it's a whammy, double whammy effect, not just from the start of the pathway, but all the way throughout it. It's making sure that very difficult to recover from. And as we know now, that rather than one enzyme that's inhibited, there are actually 291 enzymes that are known to be inhibited by glyphosate, about 30 enzymes that are stimulated. But you look at the series there and you see down at the bottom of this extract of the enzymes, you see the EPSPS enzyme and its stability constant, but look up there at glutamine synthase, very important amino acid for nitrogen metabolism. You see all those other pathways that are involved. So it's pretty hard to get away and miss a very important and critical enzyme system if you have a residual activity of glyphosate or exposure to it. Doesn't take very much. You look at a half an ounce of glyphosate, about 12 grams per acre, will reduce the uptake of a plant of iron about 50%, manganese about 80%. But then it doesn't do any good if it's just taken up in the roots, if it can't be translocated. And you'll see that iron, manganese, and zinc are all inhibited as far as translocation throughout the plant by this 12 grams per acre of glyphosate, or half an ounce of glyphosate. Very strong inhibitor of movement because it immobilizes and holds it. All of our herbicides are chelators, and a lot of our pesticides in general are strong mineral chelators. That's how they work. We may call them ALS inhibitors or photosynthetic inhibitors or shikimate inhibitors, but they all work by pulling the key out of the ignition to shut that enzyme system, specific enzyme systems down. And unless the key fits in the keyway for the enzyme, you don't see the activity, and you have a good herbicide. Most of them are very limited in their chelating ability. You see down at the bottom, a number of them that we rely on and have for a long time are copper chelators. In Evans in Canada would tell his wheat growers, said, make sure if you're going to use any of your copper chelators that Puma Gold or Tordon or 2,4-D, make sure that you get out there with an extra application of your copper fertilizers, or you're going to have a lot of ergot in your grain. Ergot's a fungus that produces the ergotamine and LSG precursors that can cause very serious crop loss, but also some other effects. We rely on ergotamine as a means of stopping hemorrhages in surgery. Our hippies during the 60s used to come up to northern Idaho and Washington and purchase all the cleanings from the grain because that's where the sclerotia from the ergot were, and that was their source of LSD for their happy days. And so, but the uniqueness of glyphosate and also your glufosinate and a couple of other materials is they're very broad spectrum chelators, so that it's not just a simple inhibition of one pathway, but you're impacting a flood of other physiological processes. We're applying about 250 million pounds of glyphosate a year in the U.S. in agriculture on various crops, as you can see here. But about another 250 million pounds is applied parks and recreation and homeowners and utility right-of-ways and forestry. So that every year we're applying about 500 million pounds of this very persistent chemical that can persist for years in our high clay content or low pH soils. So it can be an extremely persistent chemical, almost a forever chemical in that area. And as a consequence, when John Fagan analyzes some of the soils, or companies have him analyze it, and you see that we're up into thousands of parts per billion of the either glyphosate or AMPA. AMPA is the first degradation product of glyphosate. That's usually in most soils, that's where it stays. Well, you haven't detoxified glyphosate, you've actually increased its toxicity 1.5 times according to the FAO when you have that decarboxylation and that taking place. Look at the organic soils. These are in Pennsylvania, 24, and those soils haven't had any pesticides applied to them, any chemicals applied to them because they're organic for at least 9 years, and you still have a very significant amount of glyphosate as total effective glyphosate levels in those soils. So that, again, it can be very persistent. You can account for over 20 or 30 years of accumulation in many of our soils. It's not just from the direct spraying of glyphosate that we can contaminate our soils. Water is a common source now because of we've already saturated our filter strips and a lot of the earlier ways of detoxifying it through chelation, and we're seeing that direct glyphosate is now entering into our water supply, both groundwater as well as the surface water sources, so that you can have that soil contamination, or the common source for many of our animals is through their feed and through the diet. You can see this in the food and feed section here. There's some data that Dieter had collected, and you see tremendous levels that are in the feed that are going into that dry cow ration. That's the ration you'd think would be most protected, but since the cows aren't milking, it's not thought that they need the better feed, so they must get a lot poorer feed than they should have, because that's the next generation of your dairy. And you see there 3,300 parts per billion glyphosate. As Dieter mentioned, the manure sources. I had one organic grower that said that was quoted as stating that he thought that chicken manure was the best herbicide that he'd ever seen. And he said that it was he was attributing it to the calcium in the manure that he was applying for his organic crop, when it was really the manure that was carrying the herbicide, the glyphosate, from the feed that the animals were being fed. So there are a lot of sources of contamination. That flood is upon us. That's the field of pumpkins in Georgia, planted perpendicular to the previous corn rows, and you can see where the Roundup Ready corn was planted, treated with glyphosate, and you see the chelation of the manganese, magnesium, and zinc and whatnot there through the root exudates of the glyphosate from the corn. You see the long-term effects. This some of Volker Romhel's research, where you see that accumulation. Now, if you ask an agronomist that's called out by a farmer to find out why his crop doesn't look as vigorous as it used to, and they'll tell you on that right side that, well, it was a cold spring or a dry spring, or too wet a spring, never anticipating or never even considering glyphosate as the cause of that debilitating activity that was being expressed there. Ted Dutemeyer pointed out this slide, and that dead strip that you see there was where the farmer 4 years previous to this had just cleaned out his sprayer nozzles after he had made his glyphosate application on the crop for weed control. And 4 years later, it's still a dead zone from that chelation. The thing that we're concerned and have a real concern about now is that phosphorus and glyphosate have the same chelation points, or the same immobilization points in the soil, except when you apply your phosphorus fertilizer, you desorb that stabilized glyphosate in the soil, and it becomes an active herbicide then that can kill your crop or damage your crop very badly there. There's some research of bought showing that as you increase on the right, you increase the amount of phosphorus fertilizer that you may apply for optimum yield and quality of your crop, because it's a very critical nutrient. And the more you put on to meet that need, the more glyphosate that you desorb and make available then for root uptake, where it's about twice as toxic through root uptake as it is from foliar uptake. So that it's desorbed. I've seen fields that number of fields and get calls almost on a monthly basis wanting to know what happened to their crop, or they've done everything right and killed the crop because they were looking at the nutritional aspect, not recognizing that there's a tremendous killer sitting in these soils now that we need to consider and take into consideration because of the accumulation and lack of degradation of the glyphosate. It's merely chelated, detoxified as an herbicide, but still can become an active chemical and released there. If we look at the two primary means of degradation of glyphosate, the stumbling block is in the fact that as a synthetic herbicide or synthetic amino acid, we haven't had time for the organisms in the environment to really mutate or adapt to degrade it because of that unique carbon phosphate lyase enzyme that's required. You see it. That's why we have the AMPA accumulation, is because the next step requires the breaking of that carbon phosphate bond, and the organisms just don't have it. You see over here, it's after your glycine formaldehyde point there, you see that to go any further, you have to have the carbon phosphate, it's on up earlier before the sarcosine. You have to have that, or it just sits. That's as far as that degradation can go. And then when you have your GMO crops, Shiva dairy is documented and published on that just the disruption of the genetic profile of the plant, you block C1 metabolism. That's metabolism where you get rid of your toxins and that end products naturally, and it would normally be you form formaldehyde, and then the formaldehyde is normally picked up very quickly with your pyrroglutamic acid and eliminated from the environment. But so that in the GMO system, we have both inhibitors at different points in the degradation process that takes place here. Then it's just great herbicide because it's systemic, but it moves around, it goes into the root system, and then that's where it stimulates the soil-borne microorganisms that are really the herbicidal mode of action for glyphosate. And as it stimulates those soil-borne pathogens, it increases the number of diseases that we have. And it's very rapidly that within 6 hours, this in 12-foot high sugarcane plants, that within 6 hours you have more than 100 times the amount of glyphosate in the stalk tissue from a foliar application than is required to chelate with all of your positively charged mineral ions in that plant. So it's very rapid. In that 6 hour period, you can see the drop, about a 90% or 80% drop in availability then of your manganese and iron, about a 20%, 30% drop in availability of your zinc in those tissues, so it ties it up. We recognized Lyme-induced sclerosis for a long time, and in this research had shown that if you merely have an iron supplement, seed treatment, that you can overcome that pH effect on iron availability. But when you apply your glyphosate, you can see that it really knocks it down because of its strong chelating and mobilizing activity. If you add, in a normal situation, you just add your iron to the roots, to the seed, and you have very good, as you see on the right, remediation of that iron deficiency. However, if you're putting out glyphosate and you add your iron on seed treatment on the left, you only partially overcome it, so that rather than the 26 bushel, that in this situation was their non-treated yields, they only brought it up to 19 bushel because they didn't recognize that they also had a chelation of manganese and magnesium and the other elements. They were only replacing the chelation from the glyphosate effect there. My research had shown on these similar soils that if you'd also added some manganese with that iron, you'd probably had 65 bushel rather than the 56 bushel there, because you were compensating for at least two of the elements that were damaged by glyphosate. Very strong antibiotic against our beneficial organisms. You see the difference here on these soybeans with glyphosate treatment and very few nodules. And one of the things when Michael and I were in Ukraine and looking at the root systems for soybeans, you could tell which fields they'd used the glyphosate on because of the lack of nodules. There were several other characteristics. You could also tell what the herbicide was, and that very powerful inhibitor of our beneficial organisms that we've used in the past through our cultural controls for controlling many of our soil-borne diseases. So with the introduction of glyphosate, GMO crops, we see an increase in severity of over 40 diseases. In fact, not just the increase in disease, but actually some new diseases. Sudden death syndrome on soybeans didn't exist before 1996. It exists because glyphosate chelates the manganese and magnesium, and then with the fusarium glycines, you get the defoliation and sudden death syndrome. X.B. Yang at Iowa State showed that with the manganese and magnesium seed treatment, you could pretty much eliminate this disease. If you eliminate your glyphosate, you also eliminate it. As you see those green islands around the power poles going down this half-mile soybean field, that where the farmer pulled away so that he didn't break his boom on the power poles, you see that those plants are still catching the sun's energy and storing it as sugar and as protein and that, doing the job they were created to do. And you could see those green islands there around a couple of rock outcroppings because of that antibiotic effect as well as the chelating. So that, as Monica Kruger's group showed in the rumen or in the animals' GI tract, that it's toxic to all of the beneficial organisms that would normally control a lot of the common pathogens that we have serious concern with today. The salmonella, your clostridium, listeria. All of those are stimulated because all of your beneficial organisms that would normally control those pathogens are no longer present. And this is Monica Kruger's research, where you see in a normal stomach or rumen, you see the high population of the enterococcal organisms and complete suppression of your Clostridium and the toxin production there. But at 1/10 of a part per million glyphosate in the feed, you see that it's the enterococcal organisms that are inhibited, and you see the increase then of both the organisms as well as the clostridial bot toxins there. So there are also direct effects of the residual glyphosate that we have in our food and feed products. And their effects, not just in the reduced nutrient density, but also in the increased levels of other toxic products because they stimulate the pathogens. And it stimulates so that you have higher levels, about 27 times the concentration of the mycotoxins in those materials. We see the ecological disruption, but the direct effect, it's not an inert product that, in spite of what some of the salesmen were telling us from Monsanto, that it's safe enough you could drink, or it's safer than salt, and all those kinds of things. It's a very toxic chemical, but it's a chronic toxin rather than an acute toxin. So it doesn't kill you today, it takes a few days. It's a carcinogen. This is Monsanto's own research and gained under the Freedom of Information Act. You can see in their study here with low levels of glyphosate well below the EPA levels for most of those materials. And you see the carcinogenic response in the glyphosate in the glyphosate feed. In their study here, 23.8% developed the cancers. There was zero cancer development in their controls. So it's a very important, very serious carcinogen, and also the formulants that go into it. Then we have the disasters like the encephalopathy disaster in Yakima Valley, Washington in 2010. Well, in 2008, they recognized that they had invasive weeds in the three rivers going through Yakima, Hamilton, and Benton County and the Yakima Valley, and started dumping in glyphosate. EPA said it was perfectly safe, up to 700 parts per million. In 2 years, you have an 8,000% increase in anencephaly and miscarriage, devastating effects from individual as well as a societal standpoint. You see the increase in other diseases, the autism and celiac. We'll get more information from Dr. Porter and some of these things. This is the Alberta. But you see that epidemiological curve fits all of these diseases, both the plant and animal and human, and see that direct correlation with the exposure to glyphosate and the incidence of the disease. All 34 of these human diseases that we're now concerned about as epidemic diseases all have that same epidemiological curve. If you look at the CDC data and the USDA data for exposure to incidence and exposure to the glyphosate, you see that same curve. This with end-stage kidney disease. This is in Central America. 1 out of 4 sugarcane workers was dying of end-stage kidney failure, and it was traced back to the glyphosate used as a ripening agent for the sugarcane. Well, it goes out 4 or 5 weeks before exposure, and you burn the cane to get rid of the snakes. So you say, well, where are the guys getting the glyphosate? Well, every once in a while they would stop with that hand machete movement and cut off a little chunk of the stalk and chew on it. Well, that's where the glyphosate accumulates, because that's where the minerals are. And the sugar, and just to give them something to do. And 1 out of 4 in your society of 17 to maybe 35 or 40-year-olds, taking them out of the society and their critical role in that society as husbands, as workers, and that has a very debilitating effect. We found that we could develop a nutrient ripening system with just some molybdenum and boron, a little bit of manganese thrown in, and increase their yields 8%, get rid of the glyphosate and eliminate the predisposition from the glyphosate that they're experiencing there. So we have a flood that's present. It's not something you have to anticipate in the future because it's affecting us today. You can't see it or taste it or smell it, but glyphosate can slowly kill you. Now that you've been warned, please warn your neighbor because it's the ultimate killing machine. Thank you for the opportunity to be here and your support.